Jude, Charlie. If you want to make proper slime, you've come to the right place, because I'm an expert. The first thing we're going to need is this. It's a special type of glue called PVA glue.
PVA glue. Check.
Then we're going to mix it with some paint. Charlie, Jude, can you help me mix it?
Okay. Oh,
Wow.
nice.
Now, good mix. Oh, great.
Doesn't look very slimy, Kira.
Aha, not yet, Zoom. Next, we're going to need this. It's a special chemical called borax, which I've mixed up with some water.
Borax. That's a funny word.
It's the secret ingredient for really great slime. Let's add it to our mixture a little at a time.
Haha.
The trick is to start mixing it straight away. I'm going to start pouring this in. Just a little bit. Yeah, keep going. Really good.
Stir it all up. Oh yeah, it's starting to get thicker.
Yeah. Okay, we got some more.
Maybe it'll work now.
Good mix. Guys, how does it feel? Do you want to feel it?
Yeah. Fun. Yeah, it's working.
Do you want to stretch it? Yeah.
Whoa, look at that.
Yeah,
Oh,
stretch it.
gooey. Okay, now it's
No. See, it's working. How does it feel, guys?
really squishy.
Really squishy.
Mushy and gooey and slimy and what?
Really good.
How come slime is so slimy, Kira?
Well, Zoom, it's all about how the borax and the PVA glue mix together. And I can show you with this leftover spaghetti from our dinner. You could say that the PVA glue we use to make slime is really like this spaghetti. PVA is made up of tiny bits that are arranged into long shapes called polymers.
Who?
Polymers.
Oh.
They're a bit like these pieces of spaghetti. They slide over each other really easily, and that's what makes the glue runny.
Oh.
But when we add the borax, it's a bit like tying knots in the spaghetti. Guys, can you give me a hand tying knots? Here's some for you, and here's some for you. Great.
I thought you said we weren't supposed to play with our food, Kira.
It's okay if it's for an experiment, Zoom. Oh, that's really good, Charlie.
Oh, nice.
How are you getting on, Jude? Really good. Don't
Oh.
anymore. Oh, that's perfect.
Nice
That's
knot.
perfect. That's a great knot.
Oh, not bad at all.
Great, guys. Thanks so much.
Finally.
That's loads.
Yeah.
Now our spaghetti is all clumped together. And look, it doesn't slide around as easily. And that's a bit like how the glue turns from liquid into slime. So there you have it. The secret to great slime. Every time.
Okay, Zoom, this experiment needs water, food colouring, and shaving foam. First, the water goes into these jars. And now the shaving foam.
It's all white and fluffy. But it's so thick. I can't see any bubbles.
The bubbles in shaving foam are tiny, Zoom. So tiny that one can could have over 10 billion bubbles in it.
Wow. 10 billion bubbles. Fun fact, Amy.
Thanks, Zoom. And the smaller the bubbles, the thicker the foam.
How is it floating on the water like that?
Because the tiny bubbles make shaving foam light enough to float on water.
Oh, so it's thick but light. Next, we squeeze food colouring. What are they doing now?
They're adding some drops of food colouring to see how long it takes the drops to sink through the foam and into the water.
But it's so thick. Are you sure the drops will make it through?
Let's see.
Look, I can see drops. They're falling from the foam into the water like rain falling from a cloud.
Yes, Zoom. Colourful rain.
So the colourful drops are slowly falling through the thick foam and then speeding up when they reach the water?
Exactly.
Oh, it's so pretty. I could watch the rain from these foamy clouds all day. Thanks, Ellie and Kiva.
Okay, Zoom. This experiment needs wooden rollers, a few bottle caps, and a brick.
So, what is the experiment?
Theo and Amelia are going to show how humans came up with the idea for the wheel by finding ways to move this heavy brick.
Let's see how easy this brick is to move side to side.
Look how hard it is to move, Zoom. But thousands of years ago, pushing was one of the only ways humans had to move heavy things.
What are they doing now?
They're using these rollers to move the brick. See how much easier that's making it?
Oh, yeah!
Wooden logs were also used to move things that were too heavy to push. But can you see the problem with them?
Oh, they have to keep taking the rollers and moving them to the front to keep their brick moving.
Which is a bit of a nuisance, isn't it? But then someone came up with a better idea.
Oh, what kind of idea?
Wheels. Watch. Theo and Amelia are making a carriage for their brick.
Now, Theo, can you hold on the straw while I use the sellotape?
Why are they sticking on those straws?
Each straw is going to hold one of these, an axle. The axle goes through the center of the wheel and allows it to turn easily. Without an axle, a wheel wouldn't be much good. On go the wheels, and on goes the brick. And now it's time to test their carriage.
It's working really well.
It is. Remember how hard it was to push that block? Well, look how easy it is now as the wheels roll along the table.
So wheels make the job of moving heavy things much easier. That's really amazing. Nice work, Theo and Amelia.
To show us how food miles work, Stephen and Ryan are going to need their dinner.
And then what are you going to do, guys?
We're gonna find out whose dinner traveled further.
They've got chicken goujons, mashed potato, and fruit for dessert.
So they're eating the same dinner.
Not quite soon. The things on Ryan and Stephen's plates come from different places.
What kind of places?
To show us, they've made a special map of the world.
Whoa, that is one big map.
And the boys are standing on Ireland. Stephen is going to show us how far his dinner had to travel. His chicken goujons were from China.
That's a long way to travel.
Yes, and it's taking a lot of energy.
So that means a lot of food miles. Keep winding, Stephen.
Now his pineapple, which came from Central America.
Not as far, but still a long way away.
And finally, his potatoes, which came from Europe.
You must be tired after using up all that energy, Stephen.
Now it's Ryan's turn.
Hey, it's all at Ryan's feet.
That's because all the ingredients in his dinner were grown in Ireland, so they had a small distance to travel and use less energy.
Oh, and that means fewer food miles.
Exactly, Zoom. And fewer food miles is much better for us and our planet.
Bye-bye, Stephen and Ryan. Thanks for showing me that eating food from closer to home is miles better.
Okay, this experiment needs buckets, spades, some bricks, and of course, sand.
So what is the experiment?
They're going to test to see if they can build a sandcastle that's strong enough for bricks to stand on.
That sounds impossible.
Aha! But they've got a secret ingredient. Look,
What is it?
it's called oven mesh. It's usually used for cooking, but Evan and Rian are putting it in their sandcastle.
Now they're putting more in. But how does oven mesh help?
Well, in an ordinary sandcastle, water helps the grains of sand stick together. But wet sand still isn't very strong. The oven mesh gives the sand grains something to stick to, and that helps to make their sandcastles even stronger.
It looks like an ordinary sandcastle.
Yes, but with the secret ingredient. Time to test how strong it is with those bricks.
This is exciting! 1, 2, 3, 4, 5.
Oh my gosh, what is happening? Yeah!
6 blocks. Well done, boys.
And now you know the secret ingredient for super strong sandcastles.
Thanks, Evan. Thanks, Rian. Oh.
To show us how electric cars work, Christine and Adelaide are using toy cars, and they've made their own petrol station.
Oh, nice work, guys.
Adelaide's car needs more energy. And to get more energy, she pulls into the petrol station to fill up with fuel.
Just like most humans do.
That's right, Zoom. But remember, fuels like petrol and diesel are fossil fuels, which means they produce a lot of carbon dioxide.
Oh.
Now look at Christine's car, Zoom.
It's moving by itself.
It's a remote control car, powered by batteries. Electricity from the batteries gives it the energy it needs.
What's Christine doing now?
Her car is running out of energy, so she's recharging the batteries.
What's recharging?
It means putting energy back into the batteries.
So she recharges them instead of buying new batteries. Ha! That's brilliant.
And these days, lots of real cars are also powered by batteries.
Do you take the battery out of a real car to recharge it as well?
Nope. In a real car, the batteries stay inside and you plug the car in to recharge them.
Plugging in a big car. That's funny. It looks like they could be putting in petrol.
Yes, but instead they're putting in electricity. Now Christine is putting the recharge batteries back into the car.
So no fossil fuels and no CO2.
And that's how electric cars are better for the planet.
Ah, thanks, Christine and Adelaide. It was fun taking a drive with you.
Let's find out.
Today I asked all about cars. Some burn fossil fuels while others need to be charged.
Look down there, Zoom. If it's sunny, you can even charge an electric car using solar power.
Oh, well, that's a bright idea.
Speaking of bright ideas, wait till we have cars that are powered by water.
A car powered by water. I don't think that would ever work.
Well,
Let's find out. Zoom, meet the hydrogen car.
Ah, it's so small. My little car.
I'm going to fill these containers with water. And this part is called the fuel cell, which is powered by a solar panel.
the water goes into the fuel cell where it splits up into hydrogen and oxygen.
Oh, yeah! I can see bubbles! Is that hydrogen?
Yes, and these bubbles are oxygen gas.
The oxygen goes in here, and the hydrogen goes in here. Right, we've made enough hydrogen and oxygen. So now we disconnect the solar panel,
Ugh.
and the car is ready to drive. And now I'll just connect the fuel cell to the motor.
How exciting! The car is driving!
In the fuel cell, hydrogen and oxygen are joining together again to power the car.
Ah, so that's what makes the car go. But does a grown-up hydrogen car need to have its own solar panel like this one?
No, Zoom. The hydrogen can be made somewhere else using lots of solar panels or even wind turbines and then stored in big tanks until it's needed.
So in the future, hopefully lots of cars will be filling up at hydrogen filling stations.
Oh, but you have to start small. Isn't that right, little hydrogen car?
Beep beep, Mark!
The Earth is covered in oceans, forests, deserts, and mountains. But underneath the Earth's surface is a mysterious place. And we're going to find out what's down there.
By making dessert!
Oh.
The first thing we need is chocolate. And I've melted some here, but it's hot, so we have to be careful.
Is the Earth made of chocolate?
No, Zoom, it's definitely not. But the Earth is made up of 4 different layers. And by making a dessert in this bowl with lots of different layers, it's a great way to tell you about it. We're going to pretend that this chocolate is the very center of the Earth, which is called the inner core. Now,
I want that.
Yummy.
the chocolate's gonna go hard, but that's what we want, because the real inner core of the Earth is made of metal, so it's really solid. And it's hot, hotter than the surface of the sun. Do you know what the next ingredient is?
Custard.
That's right! Kieran, if you can start spooning the custard in,
Oh, gooey.
go for it.
Oh God, it's gonna hold.
It's a good thing I like custard.
Yeah.
Yeah, get a good scoop of it. We're pretending that this is the Earth's outer core, which is made of thick, liquid metal. Get some good scoops.
Yeah.
Excellent.
Nice.
That's perfect, Kieran. Right, excellent.
So we have the hard inner core and the liquid outer core. Well, what's next, Mark?
Next is jelly. The jelly is going to be what we call the Earth's mantle. That's the thickest layer. So we're going to need a good bit of jelly. Rian, scoop as much jelly as you can. Yes, that's it. Good scoops.
Oh, that's a good scoop.
Nice. Oh, yes.
It's like some water going into the water.
Excellent.
Oh, nice.
Love it. This is the thickest layer, so we do need a lot of jelly.
Why are we using jelly?
Because the mantle is part liquid, part solid, a bit like jelly.
I get it.
Love it. Well done. Scoop, scoop, scoop.
Yeah.
Scoopy, scoopy.
Okay, excellent. Great stuff, Rian. Well done. Now, just one more layer. This one's very important because it's where we live, the Earth's crust.
Oh, wow.
And we're going to use these wafers because they're very thin, just like the crust. So we're going to put them on top of the jelly.
Oh, nice.
Look at that.
Oh. Oh, what's the real crust made of, Mark?
It's made mostly of rock, Zoom. And even though it's the thinnest part of the Earth, it's still so deep that no one's ever been to the bottom of it.
Wow.
I think it's in.
That's good. Oh, look at how the wafers are wobbling on the jelly. Oh.
Well spotted, Zoom. Does anyone know what an earthquake is?
Yeah, it's kind of like jelly. It's when the earth shakes like jelly.
Yeah, that's right. Real earthquakes are caused by the Earth's mantle, moving bits of the crust around so that they scrape against each other.
Ah, so the wobbling wafers are a bit like a mini earthquake.
Kind of, Zoom. Right, there's only one thing left for us to do. Eat the Earth. Dig in, guys.
Oh, yummy. Is it nice?
Burn. That's good Earth. That is good Earth.
Crunchy crust.
Okay, Zoom, this experiment needs ice cubes, string, and salt.
So, what is the experiment?
They're going to show how to make ice melt quickly and then try to lift ice cubes using only a piece of string.
Huh? Lifting ice cubes with a piece of string? I can't wait.
Okay, Robert, let's put the
First, they're wetting the string. Next, they're putting the string on top of the ice cubes. And now they're adding some salt.
They're sprinkling it on the ice cubes. Are they going to eat them?
No, Zoom. The salt makes the ice under the string melt.
2, 3, 4.
So salt makes ice melt more quickly.
Exactly, Zoom.
But how is that going to help them lift ice cubes with a string?
15, 16.
Well, the rest of the ice is still very cold, so it makes the melted ice freeze again. And this time, it freezes to the string. But is it frozen enough for the string to pick up the ice cubes?
30. Okay. Robert, would you like to try lift it up?
Yes, it worked! They've lifted the ice up with a string. Thanks, Alexandra and Robert. What a cool experiment.
This experiment needs eggs, vinegar, and a large clear container.
So, what's the experiment, guys?
Today we are going to show you what acid can do. Tara, now can you put the egg into the container?
Oh, I love eggs! Are they going to boil them, or poach them, or scramble them, or...
No, Zoom. They're going to put one in vinegar. Eggs have hard shells, a bit like the hard skeletons of coral. And vinegar is acidic.
Acidic. Like how the ocean is becoming acidic.
Yes. And Killian and Tara want to find out what acidic vinegar does to a hard eggshell.
Ooh, that's a lot of vinegar.
Now they have to wait and see what happens to the egg.
For how long?
Until the same time tomorrow.
Hey, what happened to the egg?
The acidic vinegar has completely dissolved the shell. All that's left of it are those bits in the water.
An egg with no shell. And look, you can see the yolk inside.
Tara, now do you want to bounce it?
It's bouncy! I never saw a bouncy egg before. Oh, bounce it again, please, Tara. It broke.
Yes, Zoom, because the vinegar dissolves the shell. And acid in the ocean can dissolve coral skeletons the same way.
So that's why the coral is in trouble. Thanks for showing me, Killian and Tara, with your fantastic experiment.
Okay, this experiment needs wooden sticks and balls of putty.
So what is the experiment?
They're going to build things with different shapes and test which shape works best.
Poke it in here.
They're using the sticky putty to hold their sticks together. That's clever.
And can you see the shapes they're using?
Squares, just like my tower. I hope theirs turns out better than mine.
Let's see.
Next, we're going to move this on top.
Look, Iman and Hattie have made a tower out of squares. Now what are they doing?
They're building a second tower using different shapes.
Hey, they're adding sticks to join the corners together. Now it looks like triangles.
That's right, Zoom. And when they're finished building this tower, they're going to test both of them to see which one is stronger.
Oh, I can't wait to find out.
Time to test which is stronger. First, Iman is going to push down on the one built with squares.
This doesn't look good. The square tower has collapsed just like mine did.
This one is not that strong. It broke.
Now, Hattie is going to test the one built with triangles.
He's pushing very hard.
But see how this tower isn't collapsing. That's because the triangles spread the weight out more evenly than the squares.
Yes, pushing down hard, the triangle tower is still standing.
So what does that tell you, Zoom?
Well, if you want to build a tall tower, triangles are better than squares.
Correct.
Nice building, Amanda and Hattie.
Okay, this experiment needs paper, scissors, and a fan.
So what is the experiment?
Dara and Schaefer are going to try and catch the wind and turn it into electricity by making mini wind turbines.
Oh, what are wind turbines?
Wind turbines are a bit like Amy's pinwheel, Zoom.
Oh,
Except when they catch the wind, they can make electricity.
oh, hey, nice paper shapes.
Yes, these are going to be the parts of their wind turbines that catch the wind. The blades. Next, they're attaching the blades to their turbines. And now it's time to try and make some electricity.
Okay, so Shiva, put this onto your end.
So, where will the wind be coming from?
That big fan.
Hold it closer.
Oh, that looks windy. But how will we know if they're making electricity?
A little red light at the back of each turbine will come on, Zoom.
The mini turbines aren't turning, Mark. Is something wrong?
They just need to adjust them a little bit.
Do you want to try bending the blades differently?
Okay.
You see, the shape of the blades and how much they're turned towards the wind can make a big difference to how fast they spin.
Okay, I'll set it onto 2 again.
I hope they spin fast enough to make the lights come on this time.
This looks much better.
Then it blows, but
Yes! Dara's light has come on.
it's blowing my hair.
And so has Shifra's.
They're using their wind turbines to catch the wind and turn it into electricity.
Oh, thanks, Dara and Shifra. That was a very enjoyable spin.
This experiment needs 2 toothbrushes, toothpaste, 2 sinks, 2 buckets, and Quiva and Maeve, of course.
So what's the experiment?
Quiva and Maeve are going to test how much water we can waste when we brush our teeth.
Will it be much?
Let's find out.
First Quiva, on goes the tap. She rinses her toothbrush, and then some toothpaste. Ready, steady, brush.
There's a lot of water coming out of that tap.
For this experiment, Quiva has left the tap running, like lots of people do when brushing their teeth, even though you don't actually need water while brushing. And, under the sink, a pipe has been removed so that, instead of flowing down the drain, the water is going into the bucket. All done. Now it's Maeve's turn.
Can I have the toothpaste?
Oh, she's turned off the tap. Nice move, Maeve.
Ready, steady, brush.
Maeve's a good brusher too.
And because Maeve turned off the tap, there's hardly any water being wasted. Just a bit more for a quick rinse.
Let's see who has the most water.
Oh, I can't wait to find out.
First Quiva,
Look at all the water in her bucket. It's nearly full. I wonder how Maeve got on. Wow, that's much less water. So turning off the tap really does make a big difference. Thanks, Quiva and Maeve. You did an experiment and got your teeth nice and clean.
Okay, this experiment needs 4 empty bottles, food coloring, and water.
So what is the experiment?
Leo and Jack are going to test what happens when you put warm water and cold water bottles on top of each other.
Uh-oh, things could get messy.
Jack is filling 2 bottles with cold water. And Leo is filling 2 bottles with warm water.
But how are we going to know which is which?
That's what the food colouring is for, Zoom.
Oh, let me guess. Yellow for warm water and blue for cold water.
Correct. And they need to fill the bottles right to the top.
Why are they swapping?
Because for this experiment, they each need a bottle of warm and cold water. Now, Jack is very carefully putting the warm water on top of the cold water.
Oh, be careful not to spill any. It's going to spill everywhere. Oh, well done, Jack.
What do you think will happen now?
The water will all mix together?
Let's see.
It's not mixing together.
Look at that.
That's right, because warm water rises and cold water sinks.
Oh, so the warm water stays on top and the cold water stays on the bottom.
Exactly. Now let's see what happens when Leo does it the other way round.
Look, it's mixing together.
The warm water rises and the cold water sinks, so they mix together. Oh, and so do the colours. And they hardly spilled a drop. Nice work, Leo and Jack.
Okay, guys, I know you guys like to paint, so today we're going to paint with colours and we're going to make some new colours.
Yay! I think I'll just watch, Kira.
Okay, Zoom, I know how you don't like to get paint on that fur of yours. Okay, these are very special colours. They're called primary colours. This one is yellow, and the other 2 have really strange names. Magenta.
Magenta? Did you just make that up, Kira?
No, Zoom, that's the official name.
Oh.
And this one here is called cyan.
Cyan? It looks like blue.
It does look like blue. Okay, Cathal, I'd like you to take yellow first and start with your circle.
Okay.
Yeah,
Oh, nice.
good job.
Drippy.
Make sure you get all the corners, all the inside
staying
those
away
little
from
circles as
drippy.
well.
That's lovely and bright, Carl.
That's like goldish.
It is like gold, isn't it?
It is gold.
It's like the sun.
It is gold.
It is gold. That's a
and
really good
bright.
job. Can I have your roller? That
Good
was
job.
really, really good. Okay, Jonah, your turn. Can I give you magenta?
Yep.
And paint this circle here.
If I roll it too fast, it's gonna go really, really drippy.
Wow. These sure are pretty colours.
Now, and I want you to get in here, all in here as well.
We'll see what they look like when they mix together.
Yeah, exactly. Just in there, and that's,
Wow.
yeah, just make sure inside the line.
Oh, look! When Carl and Jonas paints mix, they make a new colour.
Absolutely. Yellow and magenta make red.
Oh, I never, yeah. I never knew that.
And now you do. Now, I'll paint the final circle with cyan.
Don't paint my hair though.
Don't paint your yellow. Well, I might do.
Oh, look, they're mixing again.
Time to mix. Oh, look, I'm mixing them. Look.
Look
And
at that.
Green.
Green.
Dark greeny black
Yeah.
in the middle.
Look, Kira. You've made green. Oh, that's the colour Carl and Jonah were looking for to paint the grass.
Yeah.
Yeah.
That's right. Yellow and cyan make green. So that's what's great about primary colours. We can make any colour we want just by mixing them in the right way.
Any colour?
Yep.
Yeah.
Even Snarkle Plus? Yeah, that's my favourite colour, guys.
You name it, Zoom, and they can make it.
All from just 3 colours. Nice painting, guys. Hey! They're still in the playground.
Yes, Zoom. All this experiment needs is a timer and a swing.
So what is the experiment?
Molly and Darren are going to count how many swings they can do in 30 seconds. And Mum is helping with the timing.
Ready?
Oh, look, Molly's going first.
For this experiment, it's important that they don't get a push at the start or while they're swinging.
3, 4,
So let's see how many swings Molly does in 30 seconds.
10.
Stop. 12 swings.
Molly did 12 swings.
And now it's Darren's turn.
She's starting higher up.
Yes, she is, Zoom.
Go.
Let's see if she does as many swings as Molly.
2.
I don't think she will, Mark. She has to go much further to get over and back.
Yes, but she's swinging much faster.
11.
Stop.
12.
Wow! Also 12 swings. So it did take both of them the same time to go over and back. Hey, what are they doing now? Are they putting their teddy on the swing?
Yep, they want to see if it also takes Teddy the same time to swing over and back.
Steady. Go.
Oh, but she's much lighter than the girls.
Yes, but remember, it should still take the same amount of time no matter who's on the swing.
4. 8. 9. 11. 12.
Stop.
12 again! It's always 12.
That's right, Zoom. Darren and Molly have proved that no matter how high it swings from or how heavy the weight at the end is, a pendulum always takes the same time to swing over and back.
Oh, nice work, Darren and Molly.
Okay, Zoom, this experiment needs 2 mini steam engines, water, and Mum's help because steam is very hot.
So, what is the experiment?
Saoirse and Roisin are going to try and get these steam engines working using steam power
So how do you make steam?
by heating up water. Mum is lighting this burner, and that's where the heat will come from.
Now we wait.
Look, Zoom, can you see that steam coming out?
Yes, I see it.
That wheel might need a little push just to get it started.
Oh, there it goes. Oh, it's activating. Look.
Oh, look, it's going all by itself.
Look, stop. Yeah, look. And the lights
Not all by itself, Zoom, by steam power. The steam causes a big buildup of pressure, enough to push the pistons and turn the wheel. Now let's see if they can get their other steam engine working. It's a model of a steam engine from long ago.
In goes the water.
Oh, that's enough, Saoirse.
And the heat will come from burning this fuel.
Careful with that fire, Mum.
Look, you can see the water starting to boil in that little window.
It's bubbling. It's bubbling.
What's Mum doing?
Listen.
Whoa! It's a whistle!
A steam-powered whistle. That means there's enough steam to start the engine. Just a little push of the wheel,
Whoa, look at it go! Oh, that's really fast!
all thanks to steam power.
Go steam power! Good job, Saoirse and Roisin.
Okay, for these tricks they need water, a straw, cooking oil, and some test tubes.
So what tricks are they going to do?
Well, one of them makes things disappear.
I love disappearing tricks.
Let's put the straw in.
First, they're putting the straw into a jar and then adding some water.
Hey, it's broken. How did they do that?
It may look like it's broken, Zoom, but it's actually just light playing tricks with our eyes. The straw looks like it's broken because the light changes direction as it travels through the glass and the water.
Wow! What's their next trick?
For this trick, Ruby and Mia need to draw some arrows. Mia is holding up the arrows behind this glass. Now, Ruby is filling the glass with water. Look what happens.
The arrows are pointing the other way.
They look like they are, Zoom, but it's just another trick caused by light.
Hey, why are Ruby and Mia wearing gloves now?
Because for their final trick, they need lots of cooking oil. It can get a bit messy.
Oh. Oh, this must be the disappearing trick. So what's Ruby putting into the oil?
It's a glass test tube. Now watch what happens.
What? Where did it go? Did it just disappear?
No, Zoom. Look.
There it is! What just happened?
It has to do with the type of glass the test tubes are made of, Zoom.
Oh.
When the light travels through the oil and the test tubes, it doesn't bend at all, so the glasses become invisible.
So, when light doesn't bend, things disappear?
That's right, Zoom. Sometimes you can't believe your own eyes.
Huh. Thanks, Ruby and Mia. Your tricks were delightful. What's the plan, guys?
Today we're going to make something new out of stuff from the recycling bin.
In other words, upcycling.
Ah,
They've got old toilet roll tubes, paper, tape, cardboard, paper clips, rubber bands, and some marbles.
so what are they going to make?
I'm not sure, but they're sticking the tubes to that white board.
Is it some kind of track?
Ah, I think I know what it is.
What, Amy?
Wait and see.
Ah, the marbles! So, what are they doing with them?
It looks like they're ready to test it out. Watch.
Oh, look at them go! That's amazing!
Yep, they built a marble run using old cardboard.
I hope they make another toy.
Okay, let's make a paper airplane.
Oh, yes! I love paper airplanes!
Noah and Ina are using a sheet of old paper.
Nice folding, Ina.
Here's a fantastic fact for you, Zoom. It's estimated that the average family uses about 6 trees worth of paper every year.
Whoa. So finding new things to do with old paper and cardboard is really helping your planet.
And now a paper clip, so their plane flies nice and straight.
Now let's make a launcher.
What are they making now?
It looks like a launcher for their plane, made of cardboard, some tape, and a rubber band.
Okay, now let's test it.
Ready for takeoff! It goes really far.
And straight, thanks to the paper clip.
Nice work, Noah and Ina. Your upcycling was so uplifting.
Okay, for this experiment, Evie and Lucy need a pizza box with an opening cut into the lid, aluminium foil, cling film, black paper, an ice pop stick, and some glue.
So what is the experiment?
We're going to make a solar oven.
A pizza box for an oven? That's clever!
Okay, Lucy, let's get started.
First, Evie and Lucy are covering the inside of the pizza box with foil. Now, they're gluing black paper to the bottom. And then covering the opening in the lid with cling film. Finally, the ice pop stick will hold open that door on the lid of the box. Now it's time to get cooking. A solar oven usually gets its heat from the sun. But because they're inside, Evie and Lucy are using a special infrared light instead.
Oh, I wonder what they're going to cook up.
Well, they've got biscuits and marshmallows and chocolate. which can only mean one thing.
S'mores! I love s'mores!
Now we have to close it over and wait.
How long do we have to wait for?
Long enough for the oven to heat up and the s'mores to melt. The energy from the light is bouncing off the foil and being absorbed by the black paper at the bottom of the oven. This warms up the paper and the heat rises. But the cling film traps the heat and keeps it inside the oven. Time to check if the s'mores are ready.
Oh, look! The chocolate is melted! The solar oven worked!
A quick blow will cool them down a bit.
And now you can eat your s'more.
Those s'mores look delicious!
Is yours nice?
So now you know how solar energy can heat things up.
Well done, Evie and Lucy. You cooked up a solar sensation.
This experiment needs a big jar of water, some eggs, and some cooking fat.
So, what's the experiment, guys?
We're going to show you how blubber helps sea animals float.
First, they're going to drop an egg in the water.
Very gently. And it sinks. Yeah.
But what has a sinking egg got to do with sea mammals?
Well, now Beth and Sarah are going to cover another egg in something that most sea mammals have. Fat. Sea mammals have a special kind of fat that keeps them warm and helps them float. It's called blubber.
Blubber. That's a funny word. They're putting a lot of pretend blubber on that egg.
Here's a fantastic fact for you, Zoom. A big sea mammal like a blue whale can have up to 75 tons of blubber in its body. That's heavier than 6 double-decker buses.
Whoa.
Okay, so is it time to drop it in the water? Yeah.
It's sinking! No, wait! It's rising back up! Hey, it's a blubbery floating egg! So blubber makes sea mammals good at floating! Great job, Sarah and Beth!
Okay, this experiment needs ribbons, sprinkles, and towels.
What do they need towels for? Uh-oh, did someone spill something? Maybe they spilled their gravy.
I don't think so, Zoom.
Let's put out this one first.
Look, they're laying out the towels on top of one another.
Now we need the brown thing.
They're pretending these are the layers in the Earth's surface.
But those towels aren't high like mountains. They're very flat.
Aha! But watch what happens when Hannah and Leah push the towels from both ends.
Oh, they're scrunching up and going all bendy. Now they look more like mountains.
Yes, Zoom. And when the layers of the Earth's surface push against each other, that can make the ground fold upwards, and that makes mountains.
Whoa, that push was very quick.
Yeah, but the Earth's surface moves very slowly. It can take millions and millions of years to make real mountains.
What are they doing now?
They're pretending those blue sprinkles are rain.
Wow, this is like a cloud and then there's like rain there.
Look, it's raining on their mountain.
And see how the rain runs down the sides. Eventually, there'll be enough water to make...
A river! Hannah and Lee are making lots of rivers.
Well, they did make a lot of rain.
Oh, so mountains are made from the ground pushing up, and rivers are made from the water running down. Good job, Hannah and Leah.
Let's start by taking a look at what floats and what sinks. And to do that, we're going to need our big tank of water. But first, Heidi, Polly, would you like to play a guessing game?
Yeah.
Yeah?
Oh, I love a good guessing game.
I want you to guess which of these 3 things is the heaviest and which is the lightest, but you can't touch them, okay? Heidi, you first.
I definitely think that the brick is the heaviest.
And what about the wood?
Think that's the second.
Okay.
And I think that's the lightest.
I think that's the lightest. Okay. Heidi, can you lift up the spoon?
Yeah.
What do you think?
It's quite heavy. I thought that it would be very light.
Yeah, a little heavier than it looks.
I know. Things aren't always what they seem. And do you want to lift up the wood?
The spoon is heavier than the wood, actually.
Oh,
Is it?
really?
Yeah.
Wow.
Very good. Do you want to try the brick?
Whoa.
The brick is very light. I thought it would be very heavy.
That's because it's made of foam. The brick is made of foam.
But that's really odd because the smallest thing was probably the heaviest and the biggest thing was the lightest.
Exactly, Zoom. Things aren't always as heavy or light as they appear. And that's because of something called density.
Density. What's that, Kira?
Density.
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 Great. Great. Let me explain. Everything is made up of tiny bits. The spoon is made up of metal and it's made up of tiny bits that are squeezed really close together. So we say that it's very dense. This big block is made of foam. So the tiny bits have a lot more space between them. So we say that it's not very dense.
Oh, what about that one?
This is made of wood, which is less dense than the metal, but more dense than the foam. And for something to float, it has to be less dense than water. So let's check that out. Heidi, Polly, can you put each of these things into the tank? And we'll see which one will float and which one will sink.
Let's do it.
Yeah.
Yeah? Well, we start with the spoon.
Okay.
Yeah.
Okay.
Do you want to come over closer? Okay, and go.
Oh,
It sank. On 1, 2, 3.
Oh. Wow.
Now, what did you think? Did you think that was going to float?
Yeah.
Will we do the brick?
Okay.
Our
Okay,
brick.
let's see. It looks heavy.
I'll make a bit of room.
Whoa, you're so strong.
You are so strong. Look at you.
Wow.
Oh, thanks, Polly. Oh, will I give you a hand?
Superhuman
Okay,
powers.
ready? 1, 2, 3. Oh.
Whoa, it floats. The metal spoon sank, but the foam block and the piece of wood are floating.
That's right. If something is less dense than water, it will float. And if something is more dense than water, it will sink.
So, Kira, the metal is more dense than water, and foam and wood are less dense than water.
Correct.
Ah. Kira,
Yes, Sue?
I wonder, am I more dense than water?
Let's not find that out, Sue. Your lovely fur would take ages to dry.
Okay, this experiment needs 2 pulley wheels, some string, and a heavy bucket.
So what is the experiment?
Henry and Freddie are going to try and use a pulley to lift that bucket.
Whoa, it looks heavy.
It is, Zoom.
Let's see if this pulley makes it easier.
Look, when they pull the string down, the bucket is lifted up. And it's easier to pull something down than to lift something up.
Oh, that's handy.
Yes, but they can make it even easier. Look,
2 pulleys? But I thought they only had 1 bucket to lift.
they do, Zoom, but 2 pulleys should make it even easier.
Lot easier.
How can that be?
See how the string is wrapped around one pulley, through the handle of the bucket, and back up through the other pulley.
Oh,
That means you need to pull twice as much string, but only half as hard, to lift the bucket up to the same height.
Wow, that was great.
nice work, Henry and Freddie.
Okay, Zoom, this experiment needs paper, scissors, and some thread.
So what is the experiment?
To test if hot air rises, Lana and Natalie are making paper snakes.
Snakes? Oh, I love snakes.
First, they're using the plates to draw circles on their paper. Next, they're drawing spiral shapes inside their circles. Now, they're cutting out their snake shapes.
How do I do that?
And finally, they're attaching some thread to hang them from.
Hey, cool snakes, Lana and Natalie.
Now we need some hot air. I agree.
Hi girls, look what I have.
And here's Mum to help.
Toaster.
She's got a toaster. Are they going to toast their snakes?
No, Zoom. The toaster will heat up the air for the experiment.
Ah, yes. Toasters do get hot. Now I know why Mom's here.
Yes, Zoom. This is an experiment you should only ever do with a grown-up's help. Lana is holding her snake over the toaster. But because it's hot, she's making sure not to touch it.
Look, Amy. Her snake is spinning. But how?
The hot air is rising from the toaster, pushing against the snake and making it spin.
This is fun.
Isn't it?
Do you want to try that? Okay.
Yay! Her snake is spinning too. So there's hot air rising up from the toaster, bumping into the snakes and making them spin and dance.
That's right, Zoom.
Uh-oh. I think all that spinning is starting to make me dizzy.
This experiment needs a banana skin, a piece of cucumber, a plastic cap, some soil, and a see-through tank.
So, what is the experiment?
We're gonna see what happens when we bury some plastic and some food underground. We're gonna bury that first.
Looks like they're burying the cucumber first.
Some layers of the soil.
In goes the soil,
Right.
now the banana,
Oh, we're gonna cover it.
and finally the plastic.
Cover your hand. Right down.
And on goes the lid.
Where are they taking it?
Somewhere safe where they can leave it for a few days.
A few days? That's ages.
You can't rush nature, Zoom.
Okay, Julia, let's see what happened. Take this out.
This is exciting.
First the cucumber.
It's like wet.
It's important to wear gloves if you're handling old food.
Hey, where's it gone?
The cucumber got munched on by teeny tiny creatures in the soil called microorganisms until it almost disappeared.
Wait, let's just keep it soil.
But what about the banana peel? It almost disappeared as well.
Yes, microorganisms love to break down most foods.
Wow. And now let's do the plastic. All right. Look, it's exactly the same.
That's because microorganisms aren't very good at breaking down plastic.
So the banana and the cucumber broke down, but the plastic stayed the same. Now I can see why humans need to stop throwing plastic away, especially single-use plastic. Great experiment, Maya and Julia. See you around.
Bye, Zoom.
Okay, this experiment needs balloons, coloured card, straws, orange juice, and pepper.
So, what is the experiment?
Well, Zoom, Annabelle and Emmanuel are going to show us how pollination works for different plants. Annabelle is using her balloon to make a bee,
Nice stripes.
and she's adding a straw for its proboscis.
Proboscis? What's that?
It's the bee's tongue, and it's shaped like a straw.
Oh.
Finally, the wings.
Oh, that sure is a cute bee.
Now I'm gonna make a butterfly.
Emmanuel is using a much longer straw.
That's because butterflies have much longer proboscises.
Ah, nice butterfly, Emmanuel.
Now you can start your flower.
Next, they're making flowers. Annabelle is sprinkling pepper on hers. That's going to be the pollen. You should always be careful with pepper, Zoom. Too much can make you
Achoo!
sneeze.
Excuse me.
For nectar, she's using cups of juice.
Flowers.
Emmanuel's flowers have a different shape. Their nectar is in long, thin containers, just like some real flowers. Time to do some pollination.
Hey, why is Annabelle rubbing her bee on her hair?
To build up static electricity, which will help with the pollination. Look! As she sucks up nectar with her proboscis, the static electricity attracts some of the pollen and it sticks to her bee. And when the bee visits the other flower to get more nectar, some of the pollen falls off onto it. And that's how pollination works. As the pollinator moves from flower to flower drinking nectar, it also carries pollen from flower to flower.
Oh, look! Emmanuel is building up static electricity on her butterfly.
And she's using her proboscis to reach the nectar in that tube.
Ah! There's no way Annabelle's bee could get in there. So that's why the butterfly's proboscis is so long.
And when she drinks from the other flower, some of it falls off. And that's what happens in nature too. Different pollinators are suited to different plants, so everyone can get some nectar and pollinate. So now you know how pollination works.
Thanks, guys. Your experiment was a pollination sensation.
Trees need a few different things to grow, and this is one of them.
A worm? Why would trees need wriggly worms, Kira?
Because of their poop.
Well, that's not what I was expecting to hear. Jane and Emily, did you know this?
No. Well, you can pick them up if you like, guys. Go for it.
Oh, okay.
They're all here.
They're slippery, isn't it?
I'm gonna hold this one too for Zoom. Worms eat bits of dead plants, and then afterwards they poop into the soil. And worm poop has things called nutrients in it, which help trees to grow.
What are these nutrients?
Nutrients are a bit like the vitamins and minerals that we humans need to keep healthy. And so they do a really important job.
Well, trees sure have a lot to thank worms for then.
That's really ticklish.
Let's find out.
Another thing that trees need to grow is water. And to show how that works, I think it's time for me to explain what happened to Kira's flowers.
Now that's something I'd really like to know.
This morning, they look like this. Would you like to see how they ended up like this?
Yeah.
Well then check out this speeded up video from the Curiosity Cam.
Oh, that's really cool, Mark. But how did you do it?
Well, Zoom, first, I added some colored food dyes to the water.
Oh,
This.
it's changing color.
Yeah. What's your favorite color, Emily?
Orange.
Well, this one's for you.
Oh, wow, that's so bright.
Yeah. And now the last one.
What color is that? Oh, that's green.
Nice.
T-shirt.
Yeah.
Yeah.
You know what I did next, guys?
Oh.
I popped in these white flowers.
Whoa.
This. Thank you. And then I waited. Can anyone guess what happened next?
Oh, I know. The flowers sucked up all the water and it turned the flower.
That's right. The colored water traveled up through the stems and out into the petals, changing their color. And I know a fun way to show how that works. Jaden, Emily, are you ready for a challenge?
Yes!
Now, I need you both to be trees.
I wish free.
That's why you're wearing those lovely tree hats on your head.
Yeah.
Now, you have some refreshing colored water down here at your roots. All you have to do is get the colored water from your roots down there, all the way to your leaves up there.
But how are they going to do that?
With these straws.
Ah.
So, I'm gonna put one end in the colored water and give the other end, one to you, Jaden, and one to you, Emily. When I say go, I want both of you to suck as hard as you can on those straws and get the water from your roots all the way to your leaves. Are you guys ready to drink like trees?
Yeah. Try.
Okay. On your marks, get set, go! See how the colored water is moving through the straws? Well, water travels up through a tree in the same way. Trees have tiny tubes inside that carry water through them, kind of like straws.
You could see it move up the straw. That's really cool.
These are hungry trees.
That's really good.
Yay, you did it! Let's check whose tongue is redder.
Wow.
Oh, nice.
Well done, guys. You'd make great trees.
Okay, this experiment needs kitchen paper, cotton wool, 2 small jars, some water, and of course, some seeds.
So what's the experiment, guys?
We're going to investigate how seeds grow.
Danny is rolling up some kitchen paper and putting it into one of the jars. And now Ben is filling the jar with...
Teeny tiny clouds.
No, Zoom, that's cotton wool.
Now I'm going to put my seed in.
Danny's planting a corn seed. Next, he sprays some water onto the cotton wool, which will soak it up until the seed needs it.
'Cause seeds love water?
That's right, Zoom. Seeds like these need 3 things to grow: water, oxygen, and the right temperature. Now Ben's turn. He's got a sunflower seed.
Will I pass you the spray? Very good.
Now they have to give those seeds time to do some growing.
How much time?
About a week.
Oh, that's ages.
Patience, Zoom. Growing takes time.
Look, what's happening?
The seeds are sprouting, Zoom. The roots are growing down in search of food and water, and the stems are growing up towards the light.
Wow, that's amazing.
Time for Ben and Danny to check on their seeds.
Have you seen the sunflower seed? It's even growing a leaf at the top.
I can't believe that with just some light, heat and water, those tiny seeds could sprout.
And now you know how a seed turns into a plant.
Thanks, Ben and Danny. Your seeds have really grown on me.
Bye, Zoom!
To show you how bogs are made, Oliver and Noah need some bark from trees, sand, cotton wool, peat, and sphagnum moss.
So what's the plan, guys?
We're gonna make bogs in bottles.
One's going to be a raised bog and one's going to be a blanket bog.
What's the difference between a blanket bog and a raised bog?
Well, blanket bogs are usually formed in places where the ground is hilly and there's lots of rain. And raised bogs are usually formed on flatter ground in lakes.
Let's make a blanket bog.
First, they're putting in some sand. This is like the soil that the bog would have started forming on around 5,000 years ago. Now some peat, just like the peat that formed on the bog from squished together plants.
That's enough, Noah. Now it's your turn to do the...
Next, some tree bark. This is like the wood from forests that grew on the bog around 4,000 years ago. Then more peat, like the peat that would have formed from the dead wood and other plants on the bog.
Making a bog sure is a lot of work.
And finally, sphagnum moss, because that's one of the most common plants found growing on bogs.
And finished. And finished.
And now for the raised bog. The cotton wool is like the white clay that would have been at the bottom of a lake around 10,000 years ago. Now some peat, just like the peat that would have formed on top of the clay in a real raised bog. Then some tree bark, because thousands of years ago, forests would have grown on raised bogs as well. Next, more peat, made from all the dead trees and other plants in the bog. And finally, sphagnum moss. In a real bog, this sphagnum moss turns into peat by dying and getting squished together over hundreds of years. But luckily, we don't have to wait that long.
Phew.
Look, There they are, 2 bogs in bottles. And now you know how bogs are made.
Yeah, thanks, Oliver and Noah.
Magnets like these are great fun to play with. Cameron, Amelia, what do you notice about magnets?
They stick together. They stick to metal. They can pick it up.
Great answers, guys.
Yeah.
And that's right. A magnet can pull things to it. It's called attraction.
But how do they do that, Kira?
Well, because every magnet is surrounded by something called a magnetic field that attracts certain things to it.
A magnetic field? That sounds exciting. I'd really like to see one.
Well, Zoom, a magnetic field is invisible, but there is a way that we can see it.
How?
Good question. So, here I put a magnet under this plastic sheet.
Yeah.
This container is filled with tiny little bits of metal called iron filings.
Oh, is that why we're wearing safety goggles?
Exactly. We have to be very careful with these, okay? So I'm going to start pouring them onto the plastic, okay? Now, we'll watch very closely.
It looks
Wow.
super sharp.
What's happening, Kira?
Well, the magnet is attracting the iron filings and arranging them in the shape of its magnetic field. So now we can see it. Can you see it, guys? What do you think?
It looks cute.
This is the magnetic field, see?
Cool. Oh. Kira, can a magnet attract anything?
No, Zoom. Magnets only attract certain kinds of metal. Like these filings, they're made of a metal called iron. And iron is very attracted to magnets. Let me show you something else.
Oh, cool.
Yeah. This is a bumblebee and it's made of paper clips. And the paper clips have iron in them. I've attached a magnet to the top of this metal frame. And the bee is attached to this thread.
Okay.
Cameron, do you want to give it a go?
Yes, please.
Oh, let's see.
Now.
Oh, wow.
Wow, that's so cool.
Yeah, it's floating in midair.
Hey, I want to try.
Go for it. Now don't let go.
Okay.
Don't let go.
Let's go straight
Keep
up.
holding it and now you can move your hand.
Oh,
Yeah.
it's like magic.
So the magnet is attracting the paper clips and the thread is holding it back.
Oh, wow. Oh, I just love magnets.
Okay, this experiment needs 4 different liquids and some marbles.
So, what is the experiment?
They're measuring the viscosity of different liquids by seeing how long it takes marbles to fall through them.
A marble race. I love marble races.
Which marble will win the race? What do you think?
The first liquid is engine oil.
Down goes the marble.
That took 4 seconds. Next, it's syrup.
And this is
Oh, it's thicker. Look how much slower the marble is going.
this is not what I was expecting.
And it took 15 seconds. So the syrup is more viscous than the oil.
Now your turn.
This is washing up liquid. And look how slowly the marble is moving through it.
This is even more viscous.
That's right, Zoom. And to reach the bottom, the marble has taken 40 seconds. And finally, honey.
Whoa! It's the slowest in the world.
Wow. That marble is taking ages to fall.
Yep, honey is very viscous.
Is it ever going to get to the bottom?
Patience, Zoom. Well, I think we know the results of the marble race, Zoom.
Yes. In first place was the marble in oil. In second place was the marble in syrup. In third place was the marble in washing up liquid. And in fourth place is the marble in honey.
Yay!
In a time of 2 minutes and 30 seconds.
So that marble lost the race. But now we know that the honey is the most viscous. Ah. Thanks, Connor and Alex. Your experiment was marvelous.
To show us why you should only put clean things in the recycling bin, Joe, Eve and Mabel need some recycling and a conveyor belt.
So what are you going to do, guys?
We're gonna play a recycling game. Are you ready? Yeah!
Eve is putting the recycling on the conveyor belt. Then it travels along the belt and drops into that tub at the end.
Going quite fast.
Joe and Mabel are looking for dirty items. If they find any, they go into those buckets. They get a point for each dirty item they find. But if they miss one and it ends up in the tub, they lose a point.
Another point! Well done, Joe! And Mabel, nice work! Oh no, they lost a point! This game is fun, Amy.
It sure is, Zoom. Do you know that some people do this for real as part of their job?
Really? Where?
In a place called a materials recovery facility. It's where our recycling goes after it's been collected from our house. The materials recovery facility has conveyor belts like Joe, Eve and Mabel's, only much bigger with a lot more recycling. The more dirty items, the harder the job of removing them.
And the job would be a lot easier if we only put clean things into the recycling. I get it!
And the guy scored 5 points.
Nice work! Thanks, guys. Your game is seriously good fun. So, what is the experiment?
Amy and Zoe are going to test what happens if you take away oxygen from a candle.
Could you light the candle?
I would have thought so.
I can see why they need Mum's help. Lighting candles is a job for grown-ups.
Baby, give Mummy a candle.
Thank you, Ames.
See those yellow flames? That's the candles using the oxygen in the air as they burn.
Will you hold them in your hand?
2, 3, go.
Now Amy and Zoe are covering each candle with a glass.
Now let's see what happens.
Why does Zoe's glass have holes in it?
Ah, watch.
The light went down.
It went out.
Amy's candle has gone out.
That's because it used up all the oxygen inside the glass, so it can't burn anymore. And Zoe's flame is still burning. Can you guess why?
Because more oxygen can get in through the holes to keep it burning?
That's right, Zoom.
3, 2, 1.
Nice work, Amy and Zoe.
Okay, Zoom, this experiment needs a large bottle of fizzy cola, a tube, and a pack of sweets.
So, what is the experiment?
They're going to use pressure to make a fizzy eruption.
Oh. Why are they using sweets, Amy?
Let's watch and find out, Zoom.
Oh, I like that sound.
That's the sound of some gas escaping from the bottle. You see, the drink is full of gas, and that's what makes it fizzy. To make enough pressure to cause an eruption, Joseph and Aoife are going to try and make nearly all of the gas in the fizzy drink escape at the same time.
How will they do that?
By dropping sweets into it. First, they're putting them into this tube. Now Joseph is attaching the tube to the top of the bottle. When they pull out that red tab, all the sweets will drop into the bottle and we should see an eruption.
This is exciting! I gotta hurt me, look! Wow! Look at all that fizzy drink! That was quite an eruption. But how do they do it?
Well, Zoom, each sweet is covered in millions of tiny holes. And inside the holes, the fizzy gas turns into tiny bubbles. But there's no space for all the bubbles inside the bottle. And that makes a lot of pressure.
And that's what caused the eruption. Ah, good job, Joseph and Aoife.
Okay, this experiment needs a big jar of water, a funnel, a test tube, some baking soda, and some seaweed.
the experiment?
We're gonna get oxygen from seaweed.
But will they be able to do it?
Let's find out.
First, they're putting some baking soda in the water and giving it a good stir. Next, they're filling the funnel up with seaweed.
A little bit of seaweed. Now I'm gonna put an extra sellotape on top so nothing falls out. Now we have to turn it upside down and put it into the middle of our bowl.
Now, David's filling the test tube with water and putting that over the funnel.
Now let's turn the light on.
That's a very bright light.
Seaweed usually needs sunlight to make oxygen, but for this experiment, David and Laura are using a light instead. And now, they just have to wait.
Mark, how will we know if the seaweed is making oxygen?
Bubble zoom.
Oh, I hope it works.
As it absorbs the light, the seaweed should start making oxygen, which will form bubbles.
Whoa, look at the bubble.
Oxygen! The seaweed is making oxygen!
That's right, Zoom. And look at how the oxygen bubbles are rising up the tube and pushing the water out of the way. Here's a fantastic fact for you, Zoom. Seaweed provides around half of the Earth's oxygen.
So it really is a superhero of the sea. Thanks, David and Laura. Your experiment was super too.
Okay, so Sarah and Paddy need a straw, a ruler, a marker, scissors, a wooden dowel, some tape, and some water.
What's the plan, guys?
We're gonna make a sprinkler.
Okay, Paddy, let's get started.
First, they're putting 2 marks on the straw to divide it up into 3 equal sections.
I'm gonna cut it.
Next, Sarah is cutting halfway through the marks to make little holes for the water to come out.
Ooh, you have to be careful with scissors.
That's right, Zoom. And Sarah is using special safety scissors. Now she's bending the straw at the cuts.
Oh, hey! It's a triangle.
They're using tape to stick their straw triangle to the wooden dowel.
Okay.
And that's Paddy and Sarah's sprinkler. Right, time to test it. They're putting a bowl of water onto a large sheet of paper.
Let's see if it works.
Oh, be careful you don't get splashed.
Sarah is using her hands to spin the sprinkler.
Wow. It's spraying everywhere, all over the sheet.
Oh, and look! The red paper makes the water easier to see. Hey, is that a field?
Yes, Zoom. Now Paddy is using the sprinkler to spray water on a model of a field.
Wow.
But how does their sprinkler work, Mark?
When you put a straw in water, some of the water climbs up into the straw. And if you bend the straw into a triangular shape and spin it around, the water inside is pulled up even higher. And if you make little holes in the corners of the triangle, the water flies out through them.
And sprinkles everywhere.
And that's how a sprinkler makes rain.
It sprays out the water by spinning really fast. Nice work, Sarah and Paddy. I really enjoyed that little spin.
Lauren, Dana, what do you know about rain?
I know that rain helps the plants grow.
And Lauren, what about you?
Well, me and Dana normally go outside when it's raining and we put our mouths out.
You like the rain?
Like, wow.
Great.
Yeah.
Really good.
That sounds like fun.
Yeah.
But Kira, how does water get up into the sky in the first place?
Well, Zoom, water in places like rivers, seas, and lakes is heated up by the sun. That turns into something called water vapor, which rises into the sky.
Oh, but what does water vapor look like?
Well, it's not something you can usually see, but I've got an experiment to show you how the water vapor gets into the sky.
Ah.
These bottles are filled with hot water, which I've colored red so they're easier to see. Now, before I add them to the tank, what do you think is going to happen?
I think it's just gonna go in there and, stay there and stuff.
like the normal water. It's
Yeah.
just hot.
Okay. Will we give it a go and see?
Yeah.
Okay, let's find out. Okay, gonna get on this side. Right. Oh, guys, get a good look.
Look at that.
Look down into the tank, further down. Yeah, see? You see what's happening?
Look, the red water's rising up and it looks so pretty.
Can you see what's happening?
Yeah. But Kira,
Yeah.
how does the red water rise up?
Yeah.
The red water is rising because it's warmer than the rest of the water in the tank.
Oh, cool.
And it's the same when the water in the rivers, seas, and lakes is heated up by the sun and turned into water vapor. The water vapor rises up.
I get it.
You get it?
So that's how the water gets up into the sky.
Exactly, Zoom. And that's the first part of our rain story.
Okay, this experiment needs corn flour, PVA glue, food coloring, and washing salt.
So how are Connor and Ava going to make a bouncy ball?
First, Connor is dissolving some of the salt in water.
They're gonna mix it.
Ava is mixing up some corn flour and glue.
So is this going to be a sticky bouncy ball, Mark?
Not when it's finished, Zoom. Next, they're adding some food coloring to give their ball a nice color.
Blue. Good choice.
Connor, will you hold this for me?
Now they're pouring the glue mixture into the salt mixture.
Oh, careful you don't spill any, Connor and Ava.
Look what's happening, Zoom. The washing salt is making the corn flour and glue clump together. Time to take it out and start turning it into a ball. Now it goes back into the salt mix. This turns the glue into a super stretchy material that can be squished and then go back to its normal shape. And that's what should make this ball bouncy. Time to test it.
Connor, let's check if our ball is bouncy.
After all of Connor and Ava's hard work, I sure hope it's bouncy. Wow! Connor and Ava's ball really is super bouncy.
It sure is, Zoom, all thanks to its squishiness. Okay, this experiment needs warm water in different colors, salt, a long cylinder, and a funnel.
So what is the experiment?
Ronan and Dara are going to test if they can make water float on water by adding different amounts of salt.
Oh, I can't wait.
I'll do the first one.
What are they doing?
They're adding salt to the water and giving it a good stir to make it dissolve.
And dissolving salt in water makes it more dense. Huh.
That's right, Zoom. But they're adding different amounts of salt to each jug to make the water in each one a different density.
Oh, that's a good idea. The colors are different in each jug, and now the densities are too.
Okay. Oh, I'll hold the cylinder.
Now they're pouring the salty water into that long cylinder, starting with the most dense one.
What are those white bits for?
They've stopped the different colors from mixing.
Perfect.
Yay. Now you take the funnel.
Now the next color. But will it float? Yes! What about this one? Will it float? Yep.
So many colors.
Yes! Each layer of water is less dense than the one below, so it floats on top of it.
So here we go. Last color. Okay, that's working.
Look, Zoom, they're finished.
It worked. Wow, it's like a rainbow.
Yes, a saltwater density rainbow.
Well done, Ronan and Dara.
Okay, this experiment needs vinegar, water, some food coloring, and 2 eggs.
So what is the experiment?
Lila and Ben are going to use the eggs to show us how toads can breathe and drink through their skin.
Okay, Lila, we're going to start our experiment now.
Okay then.
First, Lila is putting one of the eggs into a container. Now Ben is covering it in vinegar. This should dissolve the shell and make the egg permeable.
Permeable? What's that?
If something is permeable, it means that liquids and gases can pass through it.
Oh. So how long will it take before we can see if it's permeable?
Only about 24 hours.
Oh, 24 hours? That's a whole day!
Takes the egg out.
That egg looks very strange.
That's because the vinegar dissolved its shell, and that should make it permeable. They're putting it into another container with a normal egg. Now they're covering both eggs in water. Next, Lila's adding some blue food coloring.
Ooh, that's a lovely color.
And now we need to wait for another 24 hours.
Sure, I'm glad I've got a lot of patience.
Let's take the eggs out.
First, the egg with the shell,
Hey, it's turned blue.
Now I'll take my egg out.
now the egg with no shell.
Blue as well. They're both the same color on the outside.
Yes, but it's what's on the inside that counts, Zoom.
Your egg looks normal.
That's because the shell stopped the colored water getting into the egg. Now Ben's taking a look inside the egg with no shell.
It doesn't look normal.
It's all blue inside. What happened?
Without the shell, the water passed from outside to inside and made the egg change color. And that means it's...
Permeable.
And so is the skin of a toad. That's how it can breathe and drink through its skin.
Thanks, Lila and Ben. Your experiment was totally awesome.
This experiment needs 2 trays, some compost, some seeds, and a watering can.
So, what's the experiment, guys?
We're going to be making a mini greenhouse and test if plants grow faster inside or outside. Okay, let's get started. Okay.
First, Adon and Avon scoop some compost into the trays.
Okay, just plant our seeds. Okay. How many are you putting?
Next,
4.
they make some holes in the compost with their fingers, pop a seed into each hole, and then fill in the holes again.
Okay, let's water the plants.
It's raining. Drink up, thirsty seeds. Where are they taking their seeds?
Outside to the garden. That way, the seeds can get the sunlight they need to grow. And look, they're putting a glass tank over one of the trays to turn it into a greenhouse.
Hey, it fits perfectly.
This thermometer shows how warm it is. And it's already getting warmer inside the greenhouse. And now they just have to wait for a week or 2 to see how their seeds get on.
And then I'm going for a long nap.
Look, Zoom. Their seeds are ready to be checked.
Look at mine.
Hey, Edons have grown way more than Avons.
And do you know why that is?
Because Edon seeds were in the greenhouse?
That's right, Zoom. The warmer air inside the greenhouse made those plants grow more quickly.
Thanks for showing me how a greenhouse works, Edon and Avon.
Bye, Zoom.
To show you how birds build their nests, Nama and Liliana need twigs, grass, mud, and moss.
Ooh, this should be fun.
They're using these things to make a blackbird's nest. First, some twigs. Blackbirds build their nests in the branches of trees. Now they're twisting some grass around the twigs to make the nest stronger.
Now we got the mud.
Mud? What are they going to do with mud?
Blackbirds use mud to hold their nests together, a bit like cement.
Mud cement? Ooh, that's very clever.
And finally, some nice soft moss so that the nest is comfy to sit in.
Oh, look, it's just like a real blackbird's nest.
Birds build their nests so they have a safe place for their eggs and to raise their chicks. That's why they build them up high, and they come in all shapes and sizes. This swallow's nest is made from clay. Swallows' nests can be found on the walls of houses or barns or even under bridges. And look, Nama and Liliana have built a swallow's nest too.
So cool.
Thanks, Liliana and Nama. Your nests are the best.
Okay, Zoom, this experiment needs vinegar, baking soda, and some ready-made crystals.
So, what is the experiment?
Sophie and Patrick are going to try and grow their own crystals called hot ice crystals.
Oh.
Patrick, look, I'm going to put this vinegar into this bowl.
Okay.
Next, they add the baking soda to the vinegar.
Whoa! Look, it's fizzing off.
Then they give it a good stir so that it's all mixed together. Mum's on standby for the next bit.
Yeah.
The mixture needs to be heated up in a saucepan.
Saucepan down here.
Ah, good to have Mom's help, so.
Pour the bowl in. Well done. So we're going to heat it up.
Okay.
Okay.
Is the crystal mixture ready now?
Not quite. Sophie and Patrick have to wait a while for it to cool down.
Okay, guys, I think it's nice and cool now.
Okay.
So we're going to pour it in here.
Okay.
Careful, don't spill any.
Do my
Right.
best.
Now they're ready to grow some crystals. They're putting some ready-made crystals into the mixture. And look what happens next.
That's so cool. It's so cool.
Wow, are those the crystals?
They sure are, Zoom.
Oh, look at how quickly they're growing. And they're so white, just like snow.
They look like snow, but they're actually called hot ice crystals because they make heat as they grow.
Ooh. I mean, hot. Nice work, Sophie and Patrick. So, what is the experiment? Or should I say, experiment?
Okay, let's get started.
John and Sophia are going to try and make a parachute that can slow down a falling egg so it doesn't break. First, they need to cut this plastic sheet into a circle.
Let's open it.
Look, it's so big and round.
Yes, and that should create lots of air resistance.
Here.
Now they're using string to attach a cup to the plastic circle.
Yay, we made a parachute. Let's put an egg inside.
Time to test their parachute.
Oh dear, I'm afraid to look. It's a very long way down. I hope the egg survives.
3, 2, 1.
Go! Look, the parachute is slowing the egg down.
Oh no, it's flying away.
Touchdown!
Oh, I hope it's okay.
Yay, it's not broken. Yay.
Yes. Oh,
It's not broken.
egg survived.
And all because having a parachute meant there was enough air resistance to slow down its fall.
Thanks, John and Sophia. Excellent work, guys.
To show us how to check for drafts and keep them out, Maura and Kieran have a window.
They brought their own window? Now that is impressive.
Yes, and they're going to make a draft detector to test it for drafts.
But Mark, what is a draft anyway?
A draft is when colder air gets into the house from outside, usually through gaps that are too hard to see. First, they're using stones to weigh down 2 cardboard tubes so they don't topple over. Then Maura connects a skewer and they hang crepe paper from it.
Ooh, so nice and colorful.
Let's put the draft detector in front of the window.
Crepe paper is very light, so even the tiniest breeze will make it move. And that's how it detects drafts. Time for Maura to do the hairdryer test.
Look, the paper is moving. Is that a draft?
Yep, even with the window closed, some air is still getting through. So they need to make a draft excluder.
Ah.
A draft excluder can block up the gaps causing the drafts. Maura and Kieran are making one out of old tights and socks. Right, time to put the draft excluder on the window. And now Maura can do the hairdryer test again.
It's working, Maura.
Kieran's right. It is working. The draft detector isn't even moving a tiny bit.
That's right, Zoom. The draft excluder is blocking up the gaps and keeping the cold air out.
High five.
Oh, nice work, Maura and Kieran. What an excellent excluder.
Okay, this experiment needs a sandwich bag, vinegar, food coloring, and baking soda.
Vinegar and baking soda sandwiches. They sound yummy.
No, Zoom, it's not for eating.
Oh,
Leah and Dara are going to try and start a chemical reaction in the bag.
I can't wait to see that.
First, they're adding food coloring to the vinegar to give it a nice color.
Yeah, we need 6 tablespoons of baking soda.
What's that powder?
It's baking soda. They're putting some in their sandwich bag.
I'm gonna lay down the bag.
And in goes the vinegar. Vinegar and baking soda are the ingredients for the chemical reaction. When they mix together, they make a lot of gas very quickly. Leah is sealing the bag very tight so that all the gas will be trapped inside.
And zip.
Now they have to mix up the vinegar and baking soda and stand well back.
The bag is swelling up. Ooh, I'm so excited.
That's all the gas made by the chemical reaction. Look, there's too much pressure in the bag, so it's going to...
Explode! They made an explosion.
They sure did. See how the gas from the chemical reaction was trapped inside the bag until...